Hi. Radar target simulator is one of the key technology area for developing radar and radar based systems, especially in military applications when you require to test your radar at different target scenarios. The realistic testing in a field with actual targets is very costly affair, and also most of the times it is impractical to test. So radar target simulator allows you to test your radar system under different field conditions, simulating the target, clutter, target swirling models, that is target RCS fluctuations, onboard jammer, and several features. UTS radar target simulator, which I will be talking now, this is a demonstration setup for a target simulator. So we have set up an antenna system, units with a radar generator, this one. So I am going to explain the block diagram, how we are going to test the target simulator, this one. UTS radar target simulator allows a radar to be tested in all realistic environment, both in injection mode and radiation mode. Now I will explain the setup in which the present demonstration is being arranged. This block diagram illustrates the present demonstration setup. Let's start from here. So this is a radar scenario generator. So UTS has a different product by which a multi-radar thread scenario can be generated. But since the present focus is only generating against one radar, so this is configured to generate a radar waveform. Now this, I need a copy of this to compare with the echo. So we have a 3 dB power divider. The power divider output goes to a unit called pulse analyzer. So I'll talk about this. The 3 dB divider output, which is a radar signal, is given to an antenna. So for demonstration convenience, we have used 2.4 GHz ISM band antenna setups. So you have an Aggie antenna here which is radiating our radar signal. So that I will show at the end where is the practical arrangement being done. We are receiving the radar signal at radar target simulator through a dipole. So this received signal, so this is the actual product under demonstration, radar target simulator. So the echo, so this connects to a GUI where in PC based GUI you can set all settings. The output of this radar target simulator, which is an echo, that is being radiated through a parabolic reflector, and that parabolic reflector radiated signal is received by another parabolic reflector 2.4 GHz antenna setup. This is applied to pulse analyzer. So in a short, what is a pulse analyzer? This is our custom developed one instrument. This has simplest functionality of taking a reference signal and taking the echo, finding out the time difference between them and displaying the range that is being simulated. Let me take you to the practical setup. Now you can look at this. This is a radar target simulated product. So we'll come to this for a detail of this one. So you can see the wires being shown here. Yeah. So this radar target simulator right now is kept in a remote LAN mode. So I won't be using the front panel controls. Instead, I have a PC based GUI running here. And you can see there is a dipole. Yeah, we'll look at the PC based GUI features later. So you can look at the dipole which is receiving the radiated radar signal. So this is the parabolic reflector which is radiating the echo. And you can look at the other side where you can notice there is an Aggie which is set up on the tripod. So the Aggie which is set up on the tripod is generating the radar signal, and the parabolic reflector is receiving the radiated echo from here. So in a actual field scenario, the place where your Aggie is set up on a tripod is the one which is your radar test, that is radar unit, which is nothing but your unit under test. So that one, when it radiates the radar signal, the radar target simulator, this is a radar target simulator facility. The radar target simulator, you can also, the simplest form of this, you can call it as a radar byte facility. So which receives the radar signal, then based upon the range settings and Doppler settings, whatever other settings you made, it generates the echo and radiates it back. Okay, now let's look at the pulse analyzer and how we demonstrate and we prove that the range simulated is correct. So let me take you to one software which is developed by our company exclusively for demonstrating the radar signal and radar target simulated products. So this is the first tab of the product, which is a settings pro. What we do here, you configure the frequency. Then in the next tab, we will be capturing in channel 1 and channel 2 the pulses. So there are two channels. The radar pulse analyzer is a 2-channel product. So as you can see in the block diagram, So these are two channel products. So channel 1 is taking as a reference signal, which is nothing but copy of your radar signal, and channel 2 is nothing but the echo, which is received from the radar target simulator facility. So the purpose of this product is you configure number of pulses, you configure, for every capture, this captures 50 consecutive pulses on channel 1 and channel 2. After every 2 seconds it's going to repeat. That's the purpose of this time gap between data capture. See, the two channel powers need not be the same. So one we are feeding through the cable, other one we are receiving through the antenna system. So you can define the threshold. So what the product this software does, in fact this is having an embedded product RF and everything. So what this does, simply comparing with the threshold, whenever the magnitude of the energy of that channel crosses the threshold, whatever threshold we configured, it interprets that the received signal is a pulse. Then it measures the time of arrival of the pulse width, then power, frequency. That is for channel 1. Same 4 parameters, time of arrival, pulse width, power and frequency for channel 2. So now what happens when we are demonstrating radar target simulator, if we set up for a distance, simulating a target at a distance of 150 meter, so what happens, the to and fro distance between target and the radar is 300 meters, which simulates a delay of 1 microsecond. So when I intercept 2 consecutive pulses of channel 1 and channel 2, find out the TOA difference, it will come as 1 microsecond. Using this 1 microsecond, this time delay, to and fro delay, we are computing back what is the simulated range. So using this product and this setup, we are demonstrating multiple features of radar target simulator. Please browse other videos which are demonstrating detailed features of radar target simulator. Thank you.